Check one. Yep. Okay. Audio's getting through. Hey, everybody. Sorry for the break there. Had a random visit from the father-in-law, which was nice, but I wasn't expecting it, and kind of interrupted the stream. But that's okay. We're getting started again. So this is picking up right where it left off on the previous stream. The previous stream, I talked about what it is that I'm trying to do with the power modules and a constant voltage, constant current charger module for my battery, so that I can run all of the radio gear off the battery in my car, but then keep the battery topped up whenever the car is turned on and able to charge the battery, but at a constant current and whatnot. So there are lots of limitations to what I'm doing. Ideally, I would measure the current that the power supply is using to detect constant current on just the lead going into the battery, not including the current that goes off to the rest of the radio gear. That way the supply would supply, let's say I'm drawing 2 amps of current from my load, but I still need to charge the battery at 4 amps. Ideally, it would supply 6 amps to the central node, 4 of which will go into the battery and the other 2 will go off to the radios. But that's a project for a different day. I'm going to keep this one simple right now. I'm not going to bother trying to do remote current sensing. So last time we had started talking about the ACS 712. We were looking at modules like this. This is a different module than the one, different seller than the module we were just looking at in the previous video, but it's arguably a little bit of a better picture of it. It's just a little SOIC 8, current in, current out, and here is the data sheet for it. So it's an ACS 712. There's the schematic. Literally, it's measuring current through there. It can be AC or DC current. And you give it VCC, you give it ground, there's a pin for a filter cap, and then the output voltage is just proportional to the amount of current going through it. Let's see here. So here's like the internal diagram of it. And that is what I'm going to do. So we need to make this component. Now, if I remember correctly, yep, I got a KiCad open. Okay, so we haven't actually, so I may, this may be a little boring for you, and I apologize if it is, but this is my first time using KiCad on the new computer, and I don't think I've gotten it fully set up yet. Where do I add a library to this project? Component libraries, there we are. I'm going to need to add, nope, it's not there. It is there. It is there. It is there. It is there. Okay. So now I've got my Smitty library installed. There it is. Okay. And I need to go to the library editor. Ugh, come on. Because I need to make a new, ooh, that didn't work. A new component. Select working library. Put this in Smitty. Let's browser. Create new component. Component name ACS 712. U is correct. Number of units per package. Create. Units are not interchangeable. Show pin number, pin name, pin. Yeah. Okay. Ooh. Zoom in. Here, I'll put it up there. Put that up there. Okie dokie. Let's drop some pins. Yoink. Here, sorry, I'm going to keep this data sheet up on another screen so I can see it. You won't be able to see it while I'm doing this, but at least I'll be able to. Okay, so let's drop some pins. Pin name, IP plus, pin number 1, It is a right. Yeah, we're going to name size. Okay. 0, 1, 2, 3, 4. IP plus. Oop, oop. 2. Nope. IP minus 3. Minus 4. Yoink. Okay. Now over to the other side. Let's make this a left, and this is going to be ground, pin 5. Filter, pin 6. V out, pin 7. They call it VI out. I'm not really sure. Oh, voltage current. VI out. Pin 7, and then pin 8 is going to be VCC. All right. 1, 2, 3, 4. 1, 2, 3, 4. Okay, good. 1, 2, 3, 4. Okay, so those are on boundaries, but I want to move them out a bit. You know what? We'll do it like that. Okay. We'll do that later. Okay, very good. So that looks good. Yes. Yep. Okay. So let me place that on the board. ACS 712. Hey, look at that. Okay. Con 0102. And we'll flip that around the Y. And we'll put that there. Wait, nope. I lied. Well, we're still going to need that. In power input. Okay. Let's drop 3 more of these. Actually, you know what? Hang on. Before I do that, I'm going to draw a few things on the board or on the schematic here. I'm going to sketch up what it is that I'm trying to draw. I'll do it up in this corner. There's no boxes there. Okay. This is going to be some of the best artwork you've ever seen. Oop. And then really? Okay. And give me some text. Let's hear. No. hate the fact that enter doesn't actually close that dialog. And then, oh, whoops, not yet. Okay. So when I was talking a little earlier, thank you, Lieutenant Hummus. He says the artwork is amazing. When I was talking a little earlier about what it is I'm trying to do, this is a rough. Oh, one more thing. Trying to figure out how to represent this. We will do. Hold on. So what I don't have in here is a voltage meter. There we go. Okay. So in the simplest case, what I'm doing is I'm going to be making all of this stuff here. Let me go ahead and draw a large box around what I'm going to be doing. Okay, so the input comes in to the constant voltage, constant current buck boost module. That's external, that's that module right there. Then the output of that is going to go into this board that I'm building now. And there's going to be a current sensor on the positive rail coming in. Then from there, it's going to... stand by. I got to take this call. Hang on for a second.